Hi everyone, I am Satyam Agrawal, your instructor for this course on electrostatics. Here we'll be covering everything for CBSE, JEE Mains and JEE Advanced, class 11th and class 12th, physics, chemistry and mathematics, and I hope you'll enjoy the lecture. So before starting with the electrostatics, you must be aware that without electricity, our life will be very limited, and the foundations of electricity are based on the behavior and analysis of charges. So, to understand the roots of the topic, we first need to understand these in detail. So, to understand charges, it is essential to study their behavior and their effects in surrounding in state of rest as well as in motion. So, in this chapter, that is electrostatics, we will discuss everything that forms the basis for our knowledge in relation to these static charges. This chapter is going to build your rock solid foundation of all the types of effects produced by charges, whether at rest or in motion, which includes electric current and magnetism. So, moving on, we'll get to know that why things like these happen when you rub balloon on your hair stands up. So we experience static electricity in day-to-day life. Suppose a doorknob when touched by a finger gets charged with static charges due to friction in normal routine. That is why in dry weather touching a metal body causes electric discharge from body and we feel a slight electric shock. You must be experiencing this in your day-to-day life. And suppose when small pieces of paper which are attracted by a comb charged with static electricity after combining your hairs. So it is due to the friction that comb receives charges and by induction pieces if paper are attracted. Okay. So I hope you understand that. As you can see in the image as well, that a balloon on the boy is rubbing that on the hair and due to the static charges, the hair strands are getting the hair is stranding. Okay, so this is due to the static charges. And then you must have experienced that millions of volts build up from charge separation in clouds during lightning. You must be seeing that during rainfall and lightning. So this is all due to the static charges. So moving on, that what will you master today? So by the end of this lecture, you will have a rock solid foundation of all the concepts for all of the electrostatics. So you'll learn the definition of electric charge, the physical meaning of electric charge, the SI unit and the notations. You'll get to know the origin and types, that is the atomic structure, the positive, negative and the neutral charges. We'll discuss the conservation, quantization and additivity of charges. Moving on, we'll get to know that how different materials respond to charges, which is critical for the problems of JEE Mains and JEE Advanced. And then we'll get to know about the charging methods, satisfaction, conduction, and induction with real life examples. So all matter is made up of tiny units called atoms. So naturally, all atoms are electrically neutral, having equal amount of positive charge on the protons and the same charge on its electrons. So electrons are loosely bound particles in an atom of any material, whereas protons are tightly fused and confined within the nucleus only. So, the simplest way to charge a body is to add or extract electrons from it. You might be aware of that if you have studied this topic in the school. So, Deepali ma'am must have told you that. So, when a body is charged in state of rest or in motion, it exhibits several different phenomena and effects, applications of which are used in many practical cases in our surroundings. So all the phenomena concerned to charges, including electricity and magnetism, are divided into two parts, electrostatics and electrodynamics. So this chapter of electrostatics deals only with the study, effects and applications of charges at rest. I mean the static charges. So the word static means at rest. So moving on, what is electrostatics? So, electrostatics is the branch of physics that studies electric charges at rest, that is, the forces, fields, and the potential that they create. So, what is the difference between electrostatics and the current electricity? So, basically, in electrostatics, we do the study of charges that are at rest, that is, they are static or stationary, which is one and the same thing, that is, the forces and the fields. Whereas in current electricity, we discuss the flow of charges, that is current and circuits. So the real world applications are the photocopiers, the electrostatic precipitators, the spray painting, lightning rods, semiconductor manufacturing. All of these rely on the electrostatic principles. So this is the history of the giants who built electrostatics. This is not of much use, but as an Indian, you must be aware that whatever you are studying, what is the origin of that? I mean, who were the people who created electrostatics, and today you are studying about that. So moving on, the as I already told about the protons, electrons and the neutrons. So protons are located in the nucleus and the charge on them is plus 1.6 into 10 to the power minus 19 coulombs. Whereas on the electron is orbiting the nucleus continuously. So the charge on electron is minus 1.6 into 10 to the power minus 19 coulombs. Whereas neutron reside in the nucleus, as you can see in this image also, the neutron is residing in the nucleus and the electrons are continuously orbiting the nucleus. So neutron has no charge, so it is electrically neutral. So a body is neutral when the number of protons are equal to the number of electrons. So the charge imbalance creates net charge. I hope everyone understands this point, which is I mean this point is the most important for solving further problems in electrostatics. Okay. Moving on. What exactly is the electric charge? So as per the slide, the definition is that electric charge is an intrinsic property of matter that causes it to experience a force when placed in an electromagnetic field. So what are the key facts? We use the symbol Q for charge, or it can be small q, or you may use the caps Q, that is the big Q. Then the SI unit of charge is Coulomb, which is denoted by the letter C. And the most important thing, it is a scalar quantity. It does not have any direction because the charge is at rest. In current electricity, that does have a direction. But in electrostatics, the charge is at rest. We are talking about the static charges. So it is a scalar quantity. And the elementary charge is E, which is equal to 1.6 times 10 to the power minus 19 coulombs. So the golden rule that you must remember is that charge is always carried by matter. It cannot exist independently. So there are three types of electric charges. First one is the positive charge, then we have the negative charge and the neutral, which we already discussed in the previous slide. So charge is a property of physical matter due to which all types of electric and magnetic phenomena are produced. Every body is made up of atoms in which both positive and negative charge are there in form of electrons and protons in equal quantity. That is why by nature every body is electrically neutral. In common practice, a body can be charged by exchange of electrons as protons are confined within the nucleus of an atom, and in general cases it requires high amount of energy to extract or add a proton from the nucleus of an atom, which is not possible in normal practical situations and in natural conditions, whereas extraction of electron requires very small amount of energy, which is definitely possible in day-to-day practical conditions. So when electrons are added to a body, it gets negatively charged, and when electrons are extracted from a body, it gets positively charged. So in general, whenever we talk about a positively charged body, then it means that the body is electron deficient, and if we talk about a negatively charged body, then we consider that there are excess electrons on the body. In this chapter, by charged body, we will mean that the body is charged either by the addition or the removal of the electrons from it. Okay. So now let's discuss the three fundamental properties of charges. First one is the conservation of charge. As mentioned in the slide, total charge in an isolated system remains constant. Charge can be transferred but never be created or destroyed. That is, Q initial is equal to Q final. So basically, it is considered that for an isolated system, the net charge of system is always constant. Within the system, the charge may be transferred from one body to another body, which does not affect the net charge of the system. Thus, charge can neither be created nor be destroyed, and this is called the conservation of charge. It is also important to note that in a mechanical system, the charge on a body does not affect the inertial properties of the body. The charge on a body is invariant, that is, it does not depend on the reference frame from which a body and its different mechanical parameters are observed. Okay, so this was all about the conservation of charge. The second property is quantization of charge. So, as mentioned in the slide, that charge exists in discrete packets. So they are the integer multiples of E, that is Q is equal to NE, which we will discuss in detail in the next slide. So what is quantization of charge? The magnitude of charge of an electron is E, which is equal to 1.6 into 10 to the power minus 19 coulombs, which we discussed in the previous slides, which is also called an elementary or the fundamental charge. So whenever a body is charged, always it can attain charge in multiples of elementary charge, only as its electrons cannot be exchanged in frictions. So charge can vary on a body in steps of E. Thus, any charge on a body in nature can be expressed as an integral multiple of any elementary charge, as Q is equal to NE. Okay, charge Q is equal to N times E. Okay, where N is an any integer. Let me write that. So N belongs to a set of integers, that is 1, 2, 3, and so on. Okay. So the charge of any object can be increased or decreased in steps of E only. This is called the quantization of charge. As any physical quantity which varies in discrete steps is called a quantized quantity, and something which can vary continuously, such as time at macroscopic level, is called the continuous quantity. So this was all about the quantization of charge. The third fundamental property of charge is the additivity of charges, which is a very simple property that the net charge is the algebraic sum of all the individual charges. So the net charge Q would be equal to Q1 plus Q2 plus Q3, and so on. Okay, let's move on. So now we are going to discuss the conductors, insulators, and the charging methods. So what are conductors first of all? So conductors, as written on the slide. So in conductors, the electrons are free to move, such as in metals, the human body, and this planet Earth. Whereas in insulators, the electrons are bound tightly, such as in materials like rubber, glass, and plastic. Whereas semiconductors exhibit intermediate behavior. You will have a separate chapter on semiconductors where you will discuss about the silicon and germanium in detail and how does the semiconductors possess intermediate behavior. In this chapter, we are going to mainly focus on three methods, that is charging by conduction, by induction, and by friction. So first of all, let us talk about charging by conduction. Okay, so in conduction, direct contact allows charge to flow between bodies. So what happens is, when a charged metal body is connected to an uncharged metal body, then charge flows from charged body to the neutral body. Let me show you on this slide only. Suppose this is one body and this is another body. Then charge will flow from this body to this body. That is body A, and the second one is body B. Suppose body A is positively charged. Okay. So when a charged metal body is connected to an uncharged metal body. So suppose, let me erase this once and draw it once again. So suppose this is the charged body and this is the uncharged body, and if we turn the switch on, a charged body is connected to an uncharged body, then the charge flows from a charged body to an uncharged body, that is the neutral body. So until the potential energy of the charges on both bodies become equal, the charge keeps flowing from an uncharged body to from a charged body to an uncharged body. So this shows, yeah, sorry. So what happens is, when a charged metal body is connected to a neutral body via a switch, so when the switch is closed, as you can see in this image, I have closed the switch. So when the switch is closed, the charge flows to the neutral body and the charge is distributed on the outer surface of the bodies. So what will happen is, since the charge is flowing from this body to another body, this is positively charged. So what is happening, as the charge keeps flowing, the charge is distributed on the outer surface of the body. just like this, as you can see in this slide. So in later part of this chapter, we will discuss about the numerical calculation of the amount of charge after redistribution between two metal bodies. Okay. So this was all about charging by conduction. Now charge distribution on an isolated conductor. Suppose, let's erase this first. Now let us talk about the charge distribution on an isolated conductor. Suppose this is an isolated conductor, okay? So when some charge is applied to an isolated conductor, then due to manual repulsion within the volume of the body, the charge is distributed on the outer surface of the conductor in such a manner that the surface charge density. So what is surface charge density? It's Coulomb per meter square. This is called the surface charge density. You can just take a note on it, which remains inversely proportional to the local radius of the curvature of the body surface at any point. I know you might be getting confused at what is the body surface, that is the curvature of the body surface. I'll explain that in detail. So suppose this is a conductor which is having a random shape, okay? And at different points on surface it has different radii. Suppose this is a different radii, this is a different radii, then this part is having a different radii. So at different points it is having a different radii, okay? So this is the curvature, this whole part is the curvature, this is the curvature, then this is the curvature, and having different radii. So when charge is supplied on it, let me show that. So what happens is the surface charge density is inversely proportional to the radii. Okay. So the surface charge density is inversely proportional to the radii. So when charge is supplied to this conductor, it is distributed on its outer surface with varying surface charge density given as Coulomb per meter square. So at different points of the surface where radius of curvature is small r under isolated conductions, the surface charge density is observed to be given as, which is proportional to radii. Okay. So this is explained, but for various applications in different questions, it is essential to understand and remember this result and stand as observation as a fact which is given here in the slide. Okay. So what will happen is, this is radii 1, suppose, and this is radii 2, then this is radii 3 and radii 4. So what will happen is, suppose let's take this. So this is a separate curvature. So charge will be deposited here in the outer surface. Then suppose this is the curvature 2. Okay. Charge will be deposited on the outer surface. So this is how the charge distribution on an isolated conductor takes place. You can just take a note of it. It is very important for solving the JEE advanced level problems. Now moving further, now let's discuss the concept of charge induction in metal bodies. So what happens is, okay, before going further on the charge induction in metal bodies, let's first discuss the friction electricity. So atoms of different materials hold their orbiting electrons with different strengths. Okay, so when two bodies of different materials are rubbed against each other due to friction, electrons from one body will get transferred to other body which has more electron affinity, And due to transfer of these electrons, one body gets positively charged and the other one gets negatively charged. Okay, suppose we take an example of a silk cloth and a glass rod. So when a glass rod is rubbed with silk cloth, then due to a higher electron affinity of silk, it extracts the electrons from the glass rod and gets negatively charged, and the glass rod becomes positively charged. Okay, and similarly, when an ebonite rod, which is a very hard rubber, is rubbed with fur, the ebonite rod gets negatively charged, whereas the fur becomes the positively charged. This process of charging bodies via friction is called the friction electricity. So by friction electricity, only non-metallic bodies can be charged, as if metal bodies are rubbed against each other. Some transfer of electrons may take place due to different materials, but due to conductivity of both bodies in contact, charges will flow back and neutralize each other. That is, the metal bodies cannot be charged by rubbing them. So at least one body must be non-metal, so that after electron transfer, due to contact, bodies will not get neutralized. Okay. So it is also important to note that two identical bodies having different charges will have different masses. So this is because that the difference in number of electrons on the bodies and these are having different charges. So that was all about the friction electricity. Now induction. So in induction, the nearby charge redistributes electrons without contact. We'll discuss the charging by induction in detail. But first of all, it is important for us to know that how does the what is the concept of charge induction in metal bodies. So to understand the concept of charge induction, first we need to understand the behavior of free electrons in a metal body. In a metal body, we can consider free electrons behave like gas atoms in a container, which are in random Brownian motion and all distributed uniformly across the volume of the body. Okay, as a neutral body contains equal number of electrons and protons, the motion of free electrons does not put any effect on total charge of the body. It always remains zero. Okay, so the concept of charge induction is largely associated with the behavior and with the motion of the free electrons in a body in presence of external charges. This is a very important point to note, that the concept of charge induction is largely associated with the behavior and motion of free electrons in a body in presence of external charges. Okay, now suppose, let me draw a figure. Okay, so this is an isolated neutral conducting body. Okay, so when a positively charged body is brought close to this body, okay, suppose we have a positive charge. This is a positive charge, and now when this positive charge is brought close to this body, then this positive charge attracts the free electrons in the neutral body. Okay, so it will attract the free electrons. So this side of the body gets positively charged and the other side of the body gets negatively charged. Okay, so these free electrons displaced towards the positive charge as shown in this figure. So towards plus Q. Okay, so the force on free electrons due to external positive charge will cause these electrons to accumulate on the surface of the body facing the positive charge, as you can see in the figure. So as the electrons are displacing towards this surface, the opposite side of the body, the surface will become electron deficient and this surface will get negatively charged as shown in the figure. But the overall charge on the body still remains zero as it is neutral. So in the process, the charges appearing on the two surfaces of the body are called induced charges, and the phenomena of separation of charges in the body by some external factor is called charge by induction. So in extended conducting bodies which are not point sized, which we call extended bodies, charge induction is a very common phenomena, as free electrons of body can easily drift and develop induced charges on the opposite faces of the body. So in case of a point sized object, as there is no separation space of charges within the body, we ignore the concept of charge induction in analyzing different situations. Now, let us talk about the charge induction in non-metals. Let me erase this first. I hope you got the concept of charge induction in metal bodies. Now, let's talk about non-metals. So to understand the charge induction in non-metals, we'll first consider a neutral atom placed nearby a charge plus Q. As you'll see, just a moment. Now suppose there is a charge plus Q, and now let me make a figure, just allow me a moment. Now this is the nucleus, and this is the electron cloud. Okay, this is the electron cloud. Okay, so in an atom we assume that its nucleus is at the geometric center surrounded by uniformly spread negatively charged electron as shown in this figure. Okay, so when a point charge is brought close to an atom, it will attract electron cloud of the atom and repel the nucleus, due to which the electron cloud gets distorted in the shape, in some random shape. Okay, I'll just draw that shape, just allow me a moment. So this is a very random shape. Okay, in this shape basically what will happen is, this was the plus Q charge. So what will happen, it is brought close to the atom, so it will attract that electron cloud and repel the nucleus, so due to which this shape happens. Let me show you more clearly. So something like this would happen. Okay, so this gets distorted. Okay, in this shape. So we can say that earlier electron cloud was uniformly spreaded in a spherical volume, so that the negative center of the charge for this electron cloud was at nucleus. But after distortion of the electron cloud, as shown in this figure, the negative center of the charge is displaced towards the left side, whereas due to the presence of an external charge Q, atom gets transferred into an electric dipole. So this is a dipole as shown in this figure. Okay, so when we place a charge near a non-conducting body, almost all of its atoms, which we call dipoles, get aligned towards the external charge as shown in this figure. As we can see, all the charges are getting aligned towards the external charge, which is plus Q, the positive charge. So this alignment of dipoles in a non-conducting body due to an external charge is called induction in non-conducting bodies or non-metals. Which, so we say this is the polarization of the non-conducting bodies. So as the separation of charges in a non-conducting bodies by a very small distance at an atomic level, so in many numerical cases, we will ignore the effect of charge induction unless we have a specified question which requires us to consider that charge. Okay. So in both the cases of conducting and non-conducting bodies, when a positive charge is brought closer, opposite charges are developed in the bodies due to charge induction, and the negative induced charge is close to the external positive charge as compared to the positive induced charge. Hence, always the body is attracted towards the external charge, as we can see in this figure. That is called the polarization. So this phenomena clearly explains why always a charged body attracts a neutral body. It is also obvious that in conductors, induction is more due to drift of free electrons. Hence, attractive force on neutral conducting body will be more due to any external charge. Okay. So this was all about the conductors, insulators, and the charging methods. I hope you all did understand this, and if you still face any doubts, you can always reach out to me on WhatsApp. I'll just share my contact number with the description of the video. So this was all about the part 1 of the lecture. So we learned that charge is fundamental. We saw the three core properties. We also got to know that the like charges repel and the unlike charges attract. And in the next lesson, we are going to talk about the Coulomb's law, which is the most important law for the whole lesson, which we'll be frequently using. Okay. So thank you so much, everyone.